Hello, I'm here today to answer the question of how many liters of ammonia gas can be formed from the reaction of 150 liters of hydrogen gas. So we are going to be using this graphic organizer today in order to answer this question. Anytime that you're looking for the amount of one substance and you're given the amount of another substance, we can use this graphic organizer. But first, before we can use that, we need to do a couple of things. We're going to write the equation. So it does tell us that we have hydrogen and an excess of nitrogen. The key word here is that it's an excess and it's a complete reaction. That means that we're not focusing on a limiting reactant in this case. Okay, so that is our, sorry, let me move that. Okay, that is our equation. Next, we need to make sure we balance it because we're going to need these coefficients. So in order to balance it, I put a 2 over here to make it 2 nitrogens, and 6 hydrogens with 3 over here to make it 6 hydrogens. All right, so now let's go ahead and use our chart. Let's see where we're starting and where we're ending. So we have a known substance, and for that it is our hydrogen and its volume. So we know we're starting here. We know we're looking for liters of ammonia, so we're also ending in volume over here for our unknown substance of ammonia. And using this, we can see exactly how many steps this is going to be. So we've got 1, 2, 3 steps. All right. Let's go ahead and focus on our first step. Our first step is going from volume to moles. And then this right here is our conversion factor. Now, these can be flipped around. So you can have moles on top or you can have liters on top. And let's talk about how we determine what goes on top. Okay, so here, convert liters of hydrogen gas into moles. So we have liters that we're starting with. And so to determine if you're putting liters or moles on bottom, you're putting on bottom whatever is going to cancel these units out because we do not want those units anymore. Now we want moles. So in order to cancel that out, we need to put these on bottom. Okay, then when you put it in a calculator, you get, well, a much bigger answer than this, but I rounded using my sig fig rules. I've got 1, 2, 3 significant figures. And so here I needed to have 3 significant figures. Okay, so let's look at our chart. For our next step, it says moles to moles, and it says use coefficients from balanced chemical equation. So this is why we had to balance right here. Okay. Once again, I have moles of H2 here. So in order to cancel that out, I need to put moles of H2 here. I did use this 3 because of this 3 here, and I used this 2 because of this 2 here. Okay, last but not least, let's look at our final step. We did say it was going to be 3 steps, so that's how I know I'm on my last step. So to go from moles to volume, we use the same equation right here that says 1 mole per 22.4 liters, except this time you can see that I put the equation backwards than I did up here. I have moles on the bottom this time because I needed to cancel out the moles. And that finally gives us our answer of 100 liters. Okay, now a quick tip of something you can do when you're going from liters to liters, if the temperature stays the same, and we just assume that it is STP, so standard temperature and pressure. Since this conversion factor and this conversion factor are the same, you would notice that this 22.4 and this 22.4 would cancel each other out. So technically for volume only, you can actually just use your mole ratio right here. Okay, I wouldn't advise getting into the habit of that, just in case if you were going from grams to grams or grams to liters or something like that, then you could not use that shortcut. But for the case of liters to liters, you can skip these 2 steps and just do this step right here using your 150 liters to start with. All right, well, I hope you enjoyed that description. Please, if you're doing stoichiometry, make your life easier and use this graphic organizer. It is very, very helpful. Thank you.